So I want to work one more of our examples of category 4, partial fraction decomposition. And so this is our integral we're going to work. This is a polynomial divided by a polynomial. Notice the degree of the denominator is, this is 2 squared, so that's degree 4, and then multiply that. This is degree 5. This is degree 4, so this is a proper fraction. The degree of the numerator is less than the degree of the denominator. And this is in factored form. Notice also this is category 4. This has a repeated, this is quadratic, and this irreducible. So we're going to rewrite this. Just take the integrand, not the integral, take the integrand and rewrite this. And so this is algebra time at the OK Corral here. And so this is category 1, so that requires just a over x. And this is category 4. This is quadratic, so the numerator needs to be at least potentially linear. All right, and remember, every exponent, every natural number exponent less than or equal to the actual exponent present needs to be, exponent given needs to be present in the expression. So we're going to multiply everything that appears by this common denominator. Even though it's a common denominator, you treat it like a numerator. When you multiply on the left-hand side, as always, all you're left with is just this numerator because everything cancels on the left-hand side. When you multiply on the right-hand side, various things cancel. In this case, the x's cancel, but this binomial squared is still present. We'll work that here in just a bit. What's left here? When you multiply here, this x remains, and this to the first power cancels with one of these. And so that's what remains in the middle piece, the middle term. And then finally, dx plus e. Here, both of these factors cancel with both of these factors. The only thing that survives that winnowing process is the x. And so now this is algebra time. This is big time algebra here. You can go off to the side and FOIL this, right? FOIL this, and then distribute the a into all that. And if you do, you get ax to the 4th plus 8ax to the 2nd plus 16a. That is this first piece. If you FOIL this out and then distribute in the a. Let's see, the middle piece I actually have worked out here. This is bx to the 4th. Is that right? Plus 9 bx squared. And then we have plus c x to the 3rd. And then plus 9cx. I'm sorry, 4. I'm sorry, this should be a 4. So I believe that's accurate. This is b to the 3rd and the 4th power, there's that. This is bx times 4 is 4bx to the 2nd, that's that. Then we have c times x squared times x is cx to the 3rd. C times 4 times x is cx, 4cx. And then this distributes in straightforwardly. This is dx squared plus ex. So that's the big mess, is getting all those polynomials multiplied out. And now we can equate the coefficients. So what are the x to the 4th coefficients? We don't actually need to gather them. We can see what's happening. We need all the x to the 4th coefficients. Well, there's an a. There's a. That's x to the 4th. I have an a, b, c, d, e column. So there's x to the fourth. Any other x to the fourths in here? Yeah, I got bx to the fourth. And that's this one. And I believe that's all that are present. The coefficient of x to the fourth is 1. All the coefficients on the left-hand side must equal the coefficients on the right-hand side. All right, x to the third, any x to the third's present. X to the third, there's only one, cx to the third. And the x to the third coefficient on the left is 0. If there is no term, that coefficient is 0. X squared, let's see, what do we have? We have 8a. Any other squared term? There's a square. Let's see, 4bx squared. 4bx squared, that's a square. And we got plus d, so that's another. And the square coefficient on the left-hand side is 10. Now we need x to the first power. Let's see, x to the first, x to the first, x to the first. We have 4c plus e. 4c plus e is equal to the x to the first coefficient on the left, which is, again, 0. And then the constant, I believe the only constant present is 16a. So we have 16a is equal to the constant term on the left, which is 16. And so solve that system using whatever mechanism you want to use to solve that system. This actually doesn't work out too terribly because we get c for free, right? So from this immediately, we get c is equal to 0. And then from this bottom equation, we get a immediately. If 16a is equal to 16, then a must equal 1. Well, as soon as we know a is equal to 1, then this top equation tells us what b is. 1 plus b is equal to 1, so this implies b is equal to 0. We have c equals 0, which means c falls out of this equation, which means e is equal to 0. And then what's left? What's left is to find d. Notice a is 1. A is 1. So here we have 8 plus b we know to be 0. 8 plus d is equal to 10. 8, this falls out because b is 0. 8 plus d is equal to 10. So from that, we get d is equal to 2. And so that gives us these values for these coefficients. And so this antiderivative is equal to this antiderivative. A is 1, so we have 1 over x. bx plus c. b is 0, c is 0. So this entire numerator is 0. This term vanishes because coincidentally, b and c both worked out to be 0. The last piece, dx plus e. d is 2, e is 0. So we have 2x plus 0, or simply 2x over this denominator. And so this antiderivative is the same as that antiderivative up to the constant of integration. And so finding this antiderivative should be pretty straightforward. This is a natural log form. And then this piece yields to a u substitution because this is degree, this is a 4. This is degree 2, this is degree 1. So if you let u equal x squared plus 4, I think this falls up very quickly. du is equal to 2x dx, and the substitution is exact. And so this is a natural log form. This is a u substitution. That solution is very straightforward. It shouldn't be too much of a problem. If you like, I can work that the rest of the way out. Let me get some space here. I'm going to erase this to give me some more space to finish out this work. So the last little sort of denouement here, if I bring this down here, I'm going to rewrite this as 1 over x dx, which is this first piece. And then we have the integral of, we have 2x over x squared plus 4 quantity squared dx. This is the natural log form. This is let u equal x squared plus 4 du equals 2x dx. All right, so what we have is 2x dx. 2x dx is du. And this is 1 over u. So this is natural log of absolute x plus natural log of absolute u, which gives us natural log of absolute x. What was u? U was x squared plus 4. And I believe that's what we're looking for. So I think that's the final values here. It's a little scratchy all over because I had this needs to get rewritten as this second integral. But it's straightforward. You're finding the key here, really the key illustration point here is finding those coefficients. And then this antiderivative is straightforward because it's a natural log form. This antiderivative is straightforward because it's a straightforward u substitution. And so I think you should be able to handle that.